Hello stats students, this is Mrs. Mayer. I'm going to go over an example of a linear regression line, what to do on your calculator, and then how to interpret the LSRL. So we're going to start with reading the problem, which says, a runner wonders if the temperature outside impacts the number of minutes she spends running. She records the temperature and the amount of time she spends running that day for 6 consecutive days. So we can see those results in the table. The first thing is identify the explanatory variable. The explanatory variable is always your x variable, and it's always going to be in the top of your table, or on the left if it's a vertical table. Okay, so the explanatory variable here is temperature in degrees. The response variable is going to be minutes. Okay, so the LSRL is actually the formula. So that's the y hat equals a plus bx, where a is your y-intercept and b is your slope. Okay. So I'm going to pull up my calculator so you can see here, which if you cannot find your graphing calculator, you have to look on your Chromebook and type in TI. So what I'm going to do first is I have to click Stat, Edit, and I have a list in here, so I can clear these out and by arrowing up and hitting clear. So now I'm back to my calculator. I can start entering my data into L1. Okay, so now I have my L1 with temperature and my L2 in minutes. What I need to do now is hit Stat again, arrow over to Calc, and we want this number 8, linear regression, because that's what the unit we're working in. So you can press number 8 or you can arrow down. So now you can see that we're in A plus BX. Make sure you have an L1 and L2. And here where it says store equation, you need to store this equation or the line won't show up on your scatter plot. So we have to do go to vars, yvars, and number 1. Once your equation is stored from y1, you're going to hit calculate. And here is my data. What I can do now is I can go to Actions. I can take a screen capture. And I can copy and paste it in my document. Now I'm going to write my line of best fit. So as you can see, make sure your equation is at the top here. It says y equals a plus bx. So in this case, my a value is 68.61. So I'm going to do 68.61 plus my b value, well actually this is going to be minus, because it's negative, minus 0.66. Since I'm rounding to 2 decimal places, it might specify what you need to round to. That's my b value. So that is my equation. My correlation is your r value. So your correlation is your r value that determines the strength of your relationship. So this we are never going to be using in this class. So you can ignore that. You want the R value for your correlation. And that one will be rounded to 2 decimal places as well. So 0.96. When we talk about interpreting the correlation coefficient, we have to talk about two things: negative or positive, and its strength. So the closer something is to 1 or -1, the stronger it is. So this is very close to -1. So this is a strong negative correlation. Okay, so let's make our scatter plot. Let's go back to our calculator. And from here, you need to go to Graph and Zoom 9. Okay, that will give me my scatter plot. So I can take a screenshot of that, copy, and paste it to my document. Okay, there's my line of best fit and my scatter plot. So now what we have to identify is what the slope represents. So when we interpret slope, slope is a rate. Slope is also my change in y over my change in x. So when I talk about slope, I want to think about my y variable. So in this case, my slope is -0.66. So my slope is -0.66 over 1. And since slope is y over x, my y variable or response variable is minutes, and my x variable or explanatory is temperature. So what you want to think of this as is minutes over temperature. Then you can write your sentence stem as minutes decrease, because it's negative, by 0.66. The temperature increases by 1 degree Fahrenheit. Okay, the slope is a rate. Then when we talk about y-intercept is always when x equals 0. So this is a point. So your y-intercept is 0.68.61, where my 0 is my x value, which is temperature, and my 68.61 is my y value, which is minutes. So to interpret this, you say when the temperature is 0, she runs for 68.61 minutes. Okay, a lot of times this will not make sense. At this particular example, you could run outside for this long when it's 0 degrees. But a lot of times that will not make sense. So now we're going to start our predicting. So how many minutes would you expect a runner to run when it is 53 degrees outside? So they've given us an x value. So I'm going to show you two ways to figure this out. So you need to use your equation. You could say y equals 68.61 minus, I forgot the x in that, minus 0.66 times 53. So plugging it into your equation would be one way, and you would get 33.36 minutes. The other way is to go to your graph, your scatter plot, and what you're going to do is arrow up so that it's on the line. You're going to hit trace, arrow up, And then where it says x equals 56, we want to know when it's 53. So you're just going to type in 53 and hit enter. And you see this number, y equals 33.737278. So about 33.7278. So they're very close. And then the last one is, instead of giving me an x value, it's giving me the y value, right? 27 minutes is the y value. So if you use your equation, you are going to plug in 27 for y. And then solve for x. Okay, I'm not sure what that is. So once you plug it in for y, you're going to solve for x and you should get 63 degrees. Thanks for watching. Good luck on the quiz.